Given an integer array nums, we have to return an array, products, such that the ith element in products is equal to the product of all the elements of nums except the ith element of nums. There's also two restrictions. The algorithm must run in O of n time, and we cannot use the division operator. Okay, so first let's visualize this to make the problem a little clearer. Let's say the input array is 2, 3, 4, 5, 6. Then in the output array, the first element would be 3 times 4 times 5 times 6, which is 360. Notice that we didn't include 2 because 2 is also the first element in the input array. The second element in the output array would then be 2 times 4 times 5 times 6, which is 240. And the third element would be 2 times 3 times 5 times 6, which is 180. And we would continue doing this for every element in the array. Now that we've calculated every single product, we would return an array that looks like this. The values are 360, 240, 180, 144, and 120. So the way we just did it is the brute force method, where we just manually calculate every single product. This gives us the correct answer, but as you can see, this runs in O of n squared time. So how can we reduce this to O of n time? Well, take a look at this. Notice that we did 5 times 6 3 different times here. We also did 3 times 4 3 different times. And we did 2 times 3 times 4 2 times. The point I'm trying to make here is that we're doing the same calculations over and over again, and this is what's causing the inefficiency. So to improve this, first notice that each number in yellow is actually the product of two components, which are the product of all the numbers to the left of it and the product of all the numbers to the right of it. So instead of doing these calculations over and over again, we're going to calculate just once the products of all the numbers to the left of any given element and the products of all the numbers to the right of any element. Here's what I mean. So again, assume the input array is 2, 3, 4, 5, 6. Let's create an array called left, which will hold the products of all the numbers to the left of any given element. Since there is nothing to the left of the first element, we can start with the second one. The only number to the left of this element is 2, so we'll start by just putting a 2 here. For the next element, the two numbers to the left of it are 3 and 2, but instead of going back to the input array, we're going to multiply 3 with this number here that we just calculated, and you'll see why in a second. So 3 times 2 is 6. Next, we'll do the same thing. We'll multiply 4 with 6, because 6 is 2 times 3. And so this is where the efficiency comes in. Instead of going back and doing 2 times 3 again, we're going to reuse our previous calculation since we already did it. So 4 times 6 is 24. And lastly, we're going to multiply 5 by 24, because remember, 24 is 2 times 3 times 4, so this is 120. We're now done finding the products of all the numbers to the left of each element, so next, we're going to find the products to the right, using the same method but going backwards. Again, the last element has nothing to the right of it, so let's start with the second to last element. The only number to the right of this is 6, so we'll start with that. Then we'll use the same method as before. 5 times 6 is 30, so that goes here. Then 4 times 30 is 120, and finally 3 times 120 is 360. I'm going to fill in these blank spaces with 1s, and we're finally ready to calculate the final array. All we have to do is multiply each element in the left array with its corresponding element in the right array to get our answer. So for the first element, we're going to do 1 times 360, which equals 360. Next, we're going to do 2 times 120, which is 240, and it's the same thing for the rest of the array, and we end up with the same answer as before. Since creating each one of these arrays runs in O of n time, this overall algorithm also runs in O of n time. Now, before we go into the code, it turns out we actually don't even need to create these two arrays. We can do all of this using only the output array, and so I'll show you how to do that in Python. This time, the nums array will just be 2, 3, 4, 5. And the first thing I'll do is take the length of the array and save it in a variable called length, since we'll be using this a lot. So length will be 4. Next, we'll create the products array, which will contain our final answer, and initialize it to be all 1s. Then we'll start calculating the products of all the numbers to the left of each element using the exact same method that we discussed earlier. Remember, there's nothing to the left of the element at index 0, so we'll start at index 1. So like we did previously, we're going to multiply the i-1th element of the nums and products array and write it to the ith index in products. So to start, 1 times 2 equals 2. Next, 2 times 3 equals 6. And finally, 6 times 4 equals 24. The next step is to calculate the products of all the numbers to the right of each index. But instead of creating a new array, we're just going to store the products as we go in a single variable called right. And we're going to initialize that to the rightmost element in nums, which is 5. Then we'll enter a loop that traverses backwards through the arrays. And let's break down this line a little bit more. So we're going to be starting at index length minus 2, which is 2, because we know that there is nothing to the right of index 3. The ending index is -1, because remember, when using the Python range function, we don't include the ending index. So this loop will traverse backwards until it reaches index 0. And lastly, the step size is -1, which means we're going to be decrementing I. Okay, so what we're going to do in this loop is multiply each element in the products array with the variable right. So right now, 5 is the only number to the right of index 2, so we'll do 6 times 5, which is 30. Then we'll update right so that it's now the product of the last 2 elements of nums. So 5 times 4 is 20. Next we're going to do 2 times 20, because 20 is 4 times 5, which is the product of all the numbers to the right of index I. So that's going to be 40. We then update right to be 20 times 3, which is 60. And finally, 1 times 60 is 60. Right is updated to be 120, but this doesn't even matter because we're already done. The only thing left to do is to return the products array, and we are done.